Hello everyone, welcome back to the Java tutorial series. In this video, we will learn about linked list, another important implementation class of the list interface. So by the end of this video, you will understand what linked list is, how it works internally, what and all its features are, and advantages, limitations, and when to use it. So let's get started. So what is linked list? So linked list is a class that implements the list interface. Okay. Or in other words, implementation class of the list interface. Okay. So we have the hierarchy, right? Iterable and then collection, and then we have list, set, queue. So inside that list we have three implementation class. What are those? ArrayList, linked list, and vector. So what we are learning now? We are learning linked list. This is an implementation class of the list interface. So that's what it is written, implementation class of the list interface. Okay, so whatever the properties we have read for the list interface, that will automatically come for the linked list implementation class. What are those? It will maintain insertion order. That means it will remember the order of insertion. It allows duplicate elements. We can insert duplicate elements in the linked list. It supports index-based operations. So linked list also will support index-based operations. And it also implements the Deque interface. Okay. So it maintains insertion order, allows duplicate elements, and supports index-based operation, and can also be used as a queue or deque because it implements the deque interface. So we will see the internal working, how it works. Okay, unlike ArrayList, linked list does not store elements in a continuous array. Okay, in ArrayList, elements are stored in a continuous array, whereas in linked list, it stores each element inside a node. Okay. Then, what is node? This is new word which is introduced in linked list. So what is this node? So node means, suppose let's say this is node, okay? So this is one node. What it will have? So it will have data, okay? Data, and let's say it has a reference for the next node and reference for the previous node. So this is node, okay? So this structure is called doubly linked list. Okay, I will show you. So we are learning what we are learning. We are learning linked list. Okay, we will see detailed coding questions in the topic of DSA. But as part of this collection framework, I will tell you the basic things. Okay, so node. So let's say first I will linked list are also two types. Okay, singly linked list. Okay, singly linked list and doubly linked list. So I will give you both examples so that you will have better understanding. Okay, so I'm giving you first singly linked list. So let's say there is data means it can be any value, integer, string, whatever. Okay, and reference variable, you know, right? Reference variable means a variable which will be referring to an object. Okay, in this case it will be node. So every node will have data and reference. Okay, so Since this is first example, I am taking only 3 nodes. These are what nodes. Okay, node 1, node 2 and node 3. Okay, so this is a reference. It is referring to this node 2. This reference is referring to node 3. Okay, in array list, all elements we have seen is stored in a continuous memory location. Okay, these are what continuous memory allocation. See, so all elements are located in a continuous memory allocation for what? For array continuous memory, contiguous or continuous memory allocation. Okay, this is for array. But for linked list, this is what linked list, right? I'm taking an example of linked list with 3 nodes. Okay, and this reference will be referring to null. Okay, so this is example of linked list. But node 1 and node 2 and node 3 are not in a contiguous memory location. It can be anywhere in the heap memory. Okay, that's why we are having reference to this node. I hope by this time you know what is the reference. Reference means whatever may be the memory location of this node 2, that will be assigning to this reference variable, and this reference is pointing to the referring to that memory location. Similarly, this reference has the memory location of node 3. That's why it is referring to that particular memory location, that particular node. And since it is last element, so last element reference will refer to null. Okay, so this is an example of singly linked list. Okay, and suppose if you want to insert or delete any element in between, that means suppose if you want to insert some element, then let's say we have one more node and data is there and reference is there, and let's say it is node 4. I want to insert node 4 in between node 1 and node 2. So how it will be done? It will be simply by changing the reference value of all these 3, and that's how insertion and deletion will be happening. How it will be happening, what reference we need to make changes, those things will cover as part of DSA. But here you just keep in mind, like there will be just change of reference and node will insert or delete. So for linked list, insertion or deletion is faster. Insertion deletion is faster in linked list. Why? Just changing of reference variable, changing of nodes will be there. So insertion and deletion is faster. And in array list, accessing element is faster. Why? Because of indexing. And insertion deletion will be slower in array. Accessing of element will be slower in linked list. Okay, both way. So I've shown you singly linked list. I will show you now doubly linked list. Okay, so we have seen singly, we will see now doubly linked list. Doubly linked list. Okay, why we are calling that single and this one is a double? Because here we will be having 2 references. Okay, it will be reference, it will be reference. Then again another node, data, reference, and again reference, data, and reference. So why we are calling it as doubly linked list? So we are calling it doubly linked list because, okay, this is node 1, node 2, node 3. We are calling doubly linked list because we have in the middle data and left side again reference, right side another reference. Why we are having 2 reference? Because these 2 reference will refer to the front node and the previous node, next node or previous node. Similarly, this reference will refer to this node and this reference will reference to this node. So you can see double arrow, right? This is doubly linked list. And where this reference will point? Null. This, since this is first node, okay? And this is last node, so this reference will point to null. Always remember, reference will hold the memory location of node. So this reference will hold the memory location of node 2. So that's why it is referring to node 2. This reference is holding reference of node 3. That's why it is referring to node 3. And similarly, node 2, this reference, left hand side reference, is referring to previous node, which is node 1. So it will refer to previous node. And similarly, node 3, left side reference, will refer to node 2, that is previous node. So that's why it is a doubly linked list. And for this also, insertion and deletion is faster. Why? Means because there will be just changing of reference variable and we can insert or delete any node in between very fastly. So suppose in any application, if we want a frequent insertion or deletion operation, then we should prefer the linked list. Okay. So this is an advantage of linked list. And we have seen both singly linked list as well as doubly linked list. Okay. So this structure is called doubly linked list. Okay. Now let's look at the main feature of the linked list. So it maintains the insertion order. Okay. And it allows duplicate values and null values. And it will grow dynamically. Okay, as and when we add the elements, new node will get inserted or it can be removed based on our need. So we can perform insertion and deletion very frequently and efficiently. Okay, but accessing of elements by index is slower. Because why slower accessing of elements? Because linked list must traverse through the nodes in order to access the elements. So that's why accessing of element is slower. In the last point it is mentioned slower random access. Okay, since we in linked list we are having like this, right? Reference variable point to another node. So if you want to fetch the data, we want to get access of the data at particular node, then we need to traverse through each of the node. That's why slower random access. Okay. And fast insertion and deletion, because there will be change of reference variable and we can insert or delete node in between. So that's why insertion and deletion is faster in linked list. Okay. So we have seen the storage difference, how in ArrayList continuous memory allocation is allocated, whereas in linked list it is connected using reference variable. We have seen with the help of nodes. Okay. So what is the difference between these two? So the biggest difference between ArrayList and linked list is how data is stored. Okay, ArrayList will store data in continuous memory. Okay, and linked list store data, or you can say elements, as separate nodes. Okay, separate nodes connecting through references. Okay, this difference affects their performance. Okay, so how we have node, it will refer to another node. Then data, one reference, it will refer to another node. Okay, it will refer to null since it is last node. So this is linked list. Okay. So in array list, inserting or removing elements in the middle requires shifting many elements, we have seen. Okay. Let's say in array list, if we are having 1, 2, 3, okay, and let's say I will add one more 4. I want to remove this element, then this value will get removed, but these elements need to be shifted left. So this is extra what step it needs to follow. Okay. Whereas in a linked list, only reference, there will be change in reference in between, and nodes can be inserted or updated or deleted. Okay. So because of this, linked list performs insertion and deletions more efficiently. Okay, once the position is reached. So there are some common methods available in the list interface. Okay, so linked list provides all the methods available in the list interface. And additionally, because it implements Deque, it offers methods such as add first, add last, get first, get last, remove first, and remove last. So these methods make linked list useful for queue and deque operations. These are what built-in methods. Okay, we are not implementing. These methods are provided by Java. These are what built-in methods. Okay. So what are the advantages of the linked list? So it provides efficient insertion, fast deletion. Why? Because changing of reference, we can easily insert or delete a node in between. Okay. It grows dynamically, that's why dynamic in size, and no element shifting is required, as array list requires element shifting, right? But in linked list, we need to just change the reference and we can achieve. Okay, so no element shifting since it is not in continuous memory allocation. Okay, and it can be used as a list, queue, or deque. So this is the advantage of linked list. Now let's see some limitation. What are those limitations? So we have already seen random access will be slower. Why? Because we need to traverse through each node. Okay, and another drawback is extra memory is required. Why? Because we are storing not only data but a reference also. So it is memory overhead. For each node we are keeping 2 extra reference. So extra memory will be required. Okay. So apart from data, it is holding previous reference, next reference. So that's why extra memory required. Okay. So accessing elements by index is slower because nodes must be traversed one by one in the case of linked list. And it also consumes more memory than array list because every node stores additional references, that is previous reference and next reference. When should you use linked list? So we should choose linked list when your application frequently does the insertion or deletion element, insert or remove element very frequently. In that case, we should go for linked list. Okay, especially at the beginning or in the middle. It's also a good choice when implementing queue or dequeues. So if your application modify, okay, mostly reads, let's say mostly reads data using indexes, then we should go for array list. But if there are frequent insertion or deletion operation in our application, then we should go for linked list. And additionally, queue or deque operations is available as part of linked list. Okay, not suitable for frequent random access. For frequent random access, we should go for array list. Okay. So based on our need, we should pick which one to use, linked list or array list. So they have their own advantages and drawbacks. So based on our usage, our need, our requirement, we will choose the appropriate one. Okay. So linked list is useful in many real world scenarios. For example, it includes browser history, where you move backward and forward between the pages. Okay. And undo redo operation. Okay, undo redo operations in editors, music queues. Okay. Train coaches connected in sequence, ticket queues. So these are the real world examples where linked lists are used. Okay, so these scenarios benefit from efficient insertion, deletion, or traversal. Okay. So we are learning linked list. Okay. Linked list means linked list is the implementation class of the list interface. So whatever properties list is having, those will come automatically as part of linked list. Okay. So as part of this video, we are covering linked list. So let's quickly summarize what we have learned so far. Okay. So implements the list interface. Okay. Linked list is the implementation class which implements the list interface. Uses a doubly linked list internally. Okay. Internally, we have seen how doubly linked list works. It will hold two references. One is the forward and another one is the previous references. It maintains insertion order. That means the order in which values or elements are getting inserted, the same order it will be retrieved. Allow duplicates and null values. So these duplicate and null values are allowed in case of linked list. Fast insertion and deletion. Why? Because change of reference will easily available for insertion and deletion. Okay. And slower random access, because we need to traverse through each of the node in order to get the value of each node. So that's why slower random access. Okay, so that's all for this video. I hope this tutorial helped you understand the concept of linked list in Java. Thanks for watching, and I will see you in the next video.